Hey guys, and welcome to this video on algorithm analysis. So here we want to find the complexity of the following program, and we have the program in the square here, and it's a function, specifically a void function, so it doesn't return anything, and it's also called function, so a function called function that takes in an integer parameter n, and then it has the declares the int variable called I and initialize the int variable called count to 0. And then we have our for loop, and it says for I equals n divided by 2, while I is less than or equal to n, increment I by 1 each time, so I plus plus. And then our count variable gets updated by 1, so count equals count plus 1. All right, so we want to know the time complexity of this function, and I'm just going to go ahead and give you the answer first and then try to explain it. So right now it's just big O of n. So that's the answer. Big O of n. So now why is it big O of n? Right, I want to try my best to answer that question. So don't let this n divided by 2 fool you here. Let's say instead of us having n divided by 2 where I equals n divided by 2, instead of that, let's say we have I equals 1. And then let's run through the loop and see how many times this loop runs. And we could do that also by using the count variable if we want to. So let's go ahead and get started. First we have our I. Right, our I is going to equal some value. Then we're going to do a check. So we're going to see if I is less than or equal to n. And for now, let's set n to a value like 5. Okay. And then of course, I is going to increment once this is all done. So let's go ahead and look at our count variable. And there we go. Okay, so right now I equals 1. We're just not getting to the loop. So I'm going to put 1 here for I. And then is I less than or equal to n? So again, n is equal to 5. So right now we're asking, is 1 less than or equal to 5? And that's true. So I'm going to put true here. And then our count variable equals count plus 1, which is 0 plus 1, which is just equals 1. Okay, and then our I increments. And so now our I is 2, right? Increments by 1. So now it's 2 less than or equal to 5. Yes, so that's true. And then our count variable becomes 1 plus 1, which equals 2. And then our I increments. So now I equals 3. Is 3 less than or equal to 5? True. And then we get 2 plus 1, which equals 3 for our count. So now let's see our I increments to 4. Is 4 less than or equal to 5? Yes, true. So then we get 3 plus 1, which equals 4. And then I increments, we get 5. Is 5 less than or equal to 5? Yes, that's true. So then we get 4 plus 1, which equals 5. And then our I increment, so we get 6. Is 6 less than or equal to 5? That's false. So we never go here. And we're done. So how many times did this loop run? Well, or at least the inner loop. We don't want to know about the actual loop itself. The actual loop itself ran n plus 1 times, or 6 times, right? So you can see 1, 2, 3, 4, 5, 6. So it actually ran n plus 1 times. But the inner loop, which is here, you can see it only ran 1, 2, 3, 4, 5 times. So that's n times. Okay, so that's really good. Now let's say that instead our I equals 2. So that means our I starts from 2. So how many times does our loop run now? Well, if I just kind of scratch out what we did here, right? Because our I no longer starts at 1, it starts at 2. And our count is going to change. So I'm just going to erase all this here. So when we have 2, right, we check to see if 2 is less than or equal to 5, and it is. So then our count becomes 0 plus 1 here, which equals 1. And then I increments to 3. We check to see if 3 is less than or equal to 5, and it's true. So then our count becomes 1 plus 1, which equals 2. And you see it's just going to keep going on. So then we get 2 plus 1, which equals 3. 3 plus 1, which equals 4. So how many times did our inner loop run now? It's no longer n time. It's now n minus 1 times, right? Or we could say n minus I. And let me make sure I'm doing this correctly. N minus I, which would give us 3 plus 1. And the same thing as before, when I equaled 1, this ran n times, right? So we had n minus 1 plus 1, which equals n. So it ran n times. Okay? Alrighty. So now what is that? What is this number, or what is this right here in terms of asymptotic notation? This is still big O of n. So that's big O of n. Okay. So now let's suppose that I started at 3, right? So we're just going to cross this out here. So this count is going to change. The inner loop is going to run only a certain amount of times. So how many times is this inner loop going to run now? It's going to run, let's see, I is going to equal 3. Is 3 less than or equal to 5? Yes. So we do 0 plus 1, which equals 1. And then I increments to 4. Is 4 less than or equal to 5? Yes. So we do 1 plus 1, which equals 2. And then is 5, I is going to increment by 1 more time. So it becomes 5. Is 5 less than or equal to 5? Yes. So we do 2 plus 1, which equals 3. So this runs 3 times, right? Or we can also say it runs n minus I plus 1. So again, our n is 5. Our I is 3. So this equals 3, just like we wanted. So this is still big O of n. Now let's get back to our original problem, which was n divided by 2. So how many times does this run? For if I was n divided by 2. So I is no longer a specific number here. Now I is n divided by 2, right? So in this case, you know, something like 5 divided by 2 would give me 2.5. But because I is an integer, it just round down to 2. So again, this is still just n minus I plus 1. Now our I is n divided by 2. So let's go ahead and write this out. Let's do some algebra here. So we're going to pull out the n. So we get 1 minus a half plus 1. Okay, and keep doing some more algebra. So we get n times 1/2 plus 1. And one more time, make it look a little bit better. So we get n divided by 2 plus 1. So what is this? This is still big O of n. And of course, the reason why is because constants don't matter, right? So we just have a, what we really have is 1/2 times n plus 1, which is still big O of n. Okay, so thank you guys. I hope this was helpful. and I hope I explained it pretty well. I know um, a lot of the tutorials or books and things like that would simply just say this is big O of n. I kind of want to explain a little bit better why it's big O of n. So thanks as always for watching. Please leave likes, comments, any questions. Don't forget to subscribe. And I also have a tutorial on recurrence relation that kind of goes over algorithm analysis a little bit in it. If you guys want to take that course, it's on Udemy. I have it in the description below. And look out for a video on algorithm analysis that I plan on doing as well. So thanks for watching, guys, and I'll see you in the next video.